So using the law of sine, we need to show that in the triangle ABC, the following equation holds true. So let us begin. Now, let's first begin by stating the law of sine. We consider a triangle, an acute angle triangle with vertices A, B, and C. The side opposite to angle A, we're going to represent it by the letter A. This side opposite to angle B, which is AC, we're going to represent it by the letter B in lowercase. And also, the side opposite to angle C, which is AB, will be denoted by the lowercase letter c. Then the law of sines, it states that the ratio of the side A to that of angle, sine of the angle opposite to it, which is A, will be equals to the ratio of the side B to that of sine of the angle opposite to it, which is B, equals to the side C divided by sine of the angle C, which is the angle opposite to the side C. So this is the law of sines. Now what we'll do, we will consider this ratio and we will suppose that let this ratio be equals to a constant lambda. Then we can rewrite A in terms of sine A as sine A times lambda. That B will be equals to lambda times sine B and C will be equals to lambda times sine C. Right. Now let's start from the left hand side. So we have here B minus C times cotangent of A over 2. So B we will replace it with lambda times sine B. So let's take lambda as the common factor. So we have sine B minus sine C multiplied to cotangent of A over 2. Then C minus A will become lambda multiplied to sine C minus sine A multiplied to cotangent of B over 2. And finally, we have the third term. We get lambda multiplied to sine A minus sine B multiplied to cotangent of C over 2. Right. Now, we will be using the fact that sine B minus sine C, so that's given by 2 times cosine of B plus C over 2 multiplied to sine B minus C divided by 2 multiplied to cotangent of A over 2 plus the next term will be lambda multiplied to 2 times cosine of C plus A over 2 times sine of C minus A over 2 times cotangent of B over 2. And the third term will be lambda multiplied to 2 times cosine of A minus B over 2 multiplied to sine, this is A plus B multiplied to sine A minus B over 2 times cotangent of C over 2. Now, we know that in triangle ABC, the sum of the interior angles, that is A plus B plus C, that equates to pi radians. Meaning, if we have A plus B, that will be equals to pi minus C. So we can we will divide both sides by 2. So A plus B over 2, that's equals to pi minus C over 2. So let's take the tangent on both sides. So if we take the tangent of A plus B over 2, so that will be equals to tangent of pi over 2 minus C over 2. Tangent of pi over 2 minus C over 2. Here we have an odd multiple of pi over 2, so tangent must change to cotangent. We have new angle C over 2, and this is the first quadrant. And in the first quadrant, all trig functions are positive, meaning tangent of A plus B over 2. So this is equivalent to cotangent of C over 2. So similarly, we can say that tangent of B plus C over 2, so that will be equals to cotangent of A over 2. And tangent of C plus A over 2, that will be equals to cotangent of B over 2. So we have here cotangent of A over 2, cotangent of B over 2, and cotangent of C over 2. So we're going to replace it with the respective values. So let's do that. So our first term is then going to become, we have 2 times lambda multiplied to cosine of B plus C over 2 multiplied to sine b minus c over 2. So we have cotangent of a over 2 multiplied to it. So we'll replace with it tangent of b plus c over 2. Then the next term will be 2 times lambda multiplied to cosine of c plus a over 2 times sine c minus a over 2 multiplied to, we have cotangent of b over 2, which will replace with tangent of c plus a over 2. And then coming to the final term, we have 2 times lambda multiplied to cosine of a plus b over 2 multiplied to sine a minus b over 2 multiplied to cotangent of c over 2, which will replace with tangent of a plus b over 2. Fine, let's further simplify. Now, tangent of b plus c over 2 multiplied to cosine of b plus 2. So this product will be simply the sine function. So we have 2 times lambda multiplied to sine b plus c over 2 multiplied to sine b minus c over 2 plus 2 times lambda. So the product of cosine c plus a over 2 and tangent of c plus a over 2 is going to give us sine c plus a over 2 multiplied to sine c minus a over 2. And the final term will be 2 times lambda multiplied to, we have sine a plus b over 2 multiplied to sine a minus b over 2. Now, we're going to use the fact that 2 times sine theta times sine phi. So that's equals to cosine theta minus phi minus cosine of theta plus phi. So using this fact, we can combine 2 times sine b plus c over 2 times sine b minus c over 2. And this is going to give us lambda times, we'll get cosine of c minus cosine of b. Similarly, the second term will give us lambda multiplied to cosine of a minus cosine of c. And the third term is going to be lambda multiplied to cosine of b minus cosine of a. Fine. Now we can take lambda as the common factor. So we have lambda multiplied to cosine c minus cosine b plus cosine a minus cosine c plus cosine b minus cosine a. So here cosine c, negative cosine b, positive cosine b, cosine a and negative cosine a all cancels out, and this is going to give us the value 0, which is the expression on the right hand side. Hence, we have successfully shown that when using the law of sine, the b minus c multiplied to cotangent of a over 2 plus c minus a times cotangent of b over 2 plus a minus b times cotangent of c over 2, that's equals to 0.